What will happen when we connect a resistor, inductor or capacitor to alternating voltage? We know the resistor, we have a resistance, but we have to learn something new, that is reactance, and that is for the inductor and the capacitor. The reactance for the inductor is called XL, and the reactance for the capacitor is called XC. We know that the symbol for resistance is R, and the unit is ohm. And also for XL and XC, the unit is ohm. So actually the reactance is just the value of the resistance that these components has when we connect it to alternating voltage. If we look at the resistor, we have that if we connect it to a sine curve, the red one, sine voltage, then it will create a current, the blue one, and the size of the blue one depends on the value for the resistance. We can see the higher the voltage is, the higher the current will be. And if the voltage is positive, the current will also be positive. Is the voltage zero, the current will also be zero. So here we see when we use sine curves how to create a voltage current system, but we can also use vectors where over here we got the red one, the voltage for the system, and the current through the resistor. If we go into the inductor or coil, we can see we have the same voltage, the red one, but the blue one is not positioned at the right phasor as the red one. We can see here when the red one go positive, we have 0 degree, and when the blue go positive, we have 90 degree, and is lagging 90 degree, so the current will be 90 degree after the voltage. Maybe it's a little bit hard to see in this with this sine curves, but we can see it over here more easily that we have the voltage from before, but now the current is just pointed downwards or lagging 90 degree. And again, the current, the size of the current depends on the value for the reactance XL or the resistance, due to we connect it to alternating voltage. The reactance is an inductive reactance because it is a coil or inductor. This situation is for the ideal inductive reactance or ideal coil or inductor, because we must admit that when we make or create a coil, we use a wire and there is a resistance in the wire. But sometimes this resistance is that small, so it doesn't take it into account. And the value for the reactance of the coil or inductor, it depends on the frequency, because the formula said that XL is equal to 2 times pi times the frequency times the inductance for the coil. So if we change the frequency, get a higher frequency, we also get a higher reactance. And for the capacitor, we also can see that the blue current and the red voltage is not in phasor. There's a phasor shift, and in this situation the voltage still get positive here, and the current go from negative to positive here, and it is happening 90 degree in front of the voltage, so the current leading the voltage 90 degree. If we have a capacitor, it is still a reactance, it's called XC, but it is a capacitive reactance. Again, it is an ideal capacitive reactance, which means that we have no resistance in a capacitor. It is much easier to make an ideal capacitor than an ideal inductor, so normally we think that the capacitor is perfect or ideal. When you look at the vector, we can see that here the current is in front of the voltage, so it is leading 90 degrees. When we have to calculate the capacitive reactance, we have the formula down here. It is 1 divided by 2 pi frequency times the capacitance for the capacitor. So here it is opposite of the inductor or coil. If we get a higher frequency, we get a lower reactance of the capacitor. That was the basic of what will happen when we connect a resistor, inductor or capacitor to alternating voltage, and how the reactance depends on the frequency, and if it is a capacitor, the reactance will decrease when you increase the frequency, but for the coil or inductor, the reactance will increase when we increase the frequency, and it will be a linear. And for the resistance, it's not depending on the frequency, and for the resistance again, there's no phase shift, but we have the phase shift for both the inductor and capacitor, and the phase shift is the different way from the inductor and the capacitor.